So hello everyone. In this video, I will give some sort of demo on visualizing various mathematical expressions through this Desmos tool. So let's start with our basic coordinate geometry stuffs. Okay. Let's say if I will define some sort of points on ND space, or here it is 2D. So here I define a tuple of A comma B. Okay, so accordingly it will automatically create its slider views. Okay, so if I will add open the slider, then the point will move according to its boundary conditions. Right? Great. Okay, so if you will put some sort of constant like -5 to +5, and here also it's -4 to +4, right? So that point will move in this particular region, right? It's kind of a rectangular kind of region where the point will move according to that A and B. Great. Fine. Let's move into that line part. Okay, so in coordinate geometry, your basic line equation is y equals to mx plus c. So here we are having two parameters m comma c. Okay, where why there are these are called parameters because according to different m and c values we can shift or rotate our traditional line. Okay, y equal to mx plus c. Here you can see that if I will change m, then the line will rotate accordingly, either it is anti-clockwise or clockwise. Similarly, okay, so if I will change the y-intercept, okay, c, then the line will either go up or down according to the value of c. Okay, fine. Now let's move into another interesting thing called polar form. Okay, so polar form is basically if a point is located from origin at a distance of t, okay, with an angle c from x-axis, then the polar coordinate will be cos c, comma t sin c, right? This is what the polar coordinate. If I will add the slider for c, then that uh, vector from 0 to that particular polar coordinate will keep moving, rotating either clockwise or anti-clockwise according to that C, right? So here the T will follow some sort of boundary condition. Let's say if I will put the boundary condition like T will start from 0 to 4, then the vector magnitude will increase and it will, but that rotation is depending on C, not T, right? Great. Now let's do another thing. Okay, let's think of that circle, right? X square plus y square is equals to your 4. Okay, so a circle with origin at 0, 0 with radius 2, right? 2 square, basically. Okay, if I want to change the origin, okay, so what could be the possible way? So let's say I want the circle origin, the I want the circle origin to be 1 comma 2. So here I will rigidly fix 1 and here 2, then the circle will go to the this particular origin. Okay, so if I want some sort of arbitrary origin, then again I will have I will have two arbitrary variables, okay, that is h and k. Here h starts from, let's say, -8 to +8, and k starts from -4 to +4, right? Great. Now, what will happen if I fix k and start moving h, then the circle will go here and there and move along x-axis. Okay. Similarly, if I will fix h and, okay, uh, keep changing k, then the circle will go along y-axis. That's pretty much easy. Now, another thing what here I will do, I will add the polar coordinate concept. Okay, so I want some sort of a rotating kind of visualization on the top of this moving circle, right? To add some sort of rotating kind of stuff, I will uh, write my polar coordinates expression. Great. Okay. Now, so here the polar coordinate factor is having uh, origin as its starting point. Now I want to shift that vector starting point as that in the edge of that origin of circle. So the origin of circle is basically h comma k, and I shifted that to h comma k, right? And I just change, right, that t's boundary condition from 0 to 2. Let's see what happens. Okay, great. Okay, I did one axis for the circle. Okay, so if I want to slow down my rotation, then I will put it the boundary condition for c is 1 to 10. Okay, it will slowly rotate, right? Then what I want now, I want some sort of I want some more accesses, right? So to have some more accesses, okay, I just copied that previous expression and I just added one to it. Okay, so what does it mean? So it will create another axis, but the phase shift will be so some sort of phase shift type of thing will happen over here. Okay, if I will uh, change C, one particular axis will rotate and second particular axis will also rotate with some sort of phase shift, right? Accordingly, I will add some more expressions for uh, polar coordinate, let's say 3. Okay, and that T's boundary condition is something like that. And I will add some more polar coordinates over here. So here it is 2, and boundary condition for t is from 0 to 2. I will add some more, and boundary condition is from 0 to 2. Okay, I will add some more, right? Okay, so now let's see what happens. Okay, so something is rotating inside this circle. Okay, it feels like some sort of thing is rotating, or maybe a circle is rotating. Okay, along with that, if I will have this kind of stuff, okay, now a circle is rotating plus moving, right? If I will open both of this slider, then the circle will look like some sort of particle is rotating plus moving. Okay. So, this kind of thing is very simple and easy to understand and visualize. But yeah, those kind of stuffs are very much important in the case of machine learning and AI. Okay, so in my subsequent videos, I will keep uh, doing demos on such more interesting things. Okay. Okay. See you in the next video. Bye bye.